Okay, so here are the chicken bones. So this one and this one are untreated. They're just chicken bones. They're in bags so we don't get salmonella. See the hyaline cartilage. Isn't it nice and shiny? Hyaline cartilage right there. Good times.
Wait, that one's also untouched?
Yes. So
Why
this
is it broken?
this one's broken so that you can see the medullary cavity with the bone marrow inside of it. So that dark red, can you see that? That's the bone marrow. Okay, so that's our control. That's what they looked like before anything was done. Next, we have, this one was soaked, or these two, I guess, were soaked in water overnight. These two were soaked in acid overnight. Yeah. And then this one was baked for a long time. Not overnight, but for a long time.
That would be dangerous.
Yeah.
Did it make your house smell bad?
I really can't stand the smell of like bones cooking, so no.
I hate
But-
the smell of bones cooking.
But some people would have
It's
enjoyed.
like, I want a candle of that.
Okay, so what we're gonna do
Bones
first
cooking, believe
is to test the liquid that the acid-soaked bone and the water-soaked bone were soaked in for the presence of calcium. So, we're also going to test distilled water to see if that has calcium too, because it's a control. It's science. Science. Okay. Let's see. No, that's great. Dempsey, you get me a test tube.
So you're about to...
That's fine. Yeah, just an empty. Okay, so what I'm going to do is take a sample of the liquid just from the beaker. This is just the plain water beaker. You can just put it there. Thank you. I'll take a sample, just do a few drops into the test tube. And then in your paper it says sodium oxalate. Instead, I'm going to use sodium hydroxide to test for the presence of calcium. If there's calcium in the liquid, where did it come from?
Oh.
The bone, presumably, as long as our water control is negative. And we'll know that there's calcium in the water if the calcium hydroxide turns white. So if you guys think back to chemistry, when you did precipitation reactions, this is one of the ways that you could test for calcium ions. Okay, so the first one is just the plain water, just like distilled water from the distilled water machine. So this is one of our controls. Did it turn white? No. Okay, so as we expected, distilled water contains no calcium. Good. So next, I'm going to do the water that the chicken was soaked in. Blech. So again, I'll just... Yes, I will do that.
Wait, so this is a water that was soaked?
Yes.
This is the water the bones.
So this is the... This is number 4.
We just did number 2.
Did we just do number precipitation?
No, we didn't do anything.
Number 3?
Oh yeah, I think that was just our
Wait, there's...
So we did the water control,
control.
which was...
Number 4 is nothing to write down.
Yeah.
So we haven't done...
No,
So
we
it's
have
number,
not
we just
did
did number
anything.
4.
No, number 4 was
Are you
just
supposed to be recording this?
Yeah, I am.
Is it? Yes. Oh, it is still.
Yeah.
Sorry.
Okay. So water that the bone was soaked in, no reaction. The one that we're missing is the positive control. That's the issue. Positive control. Okay, so no calcium in the water that the chicken bone was soaked in. As expected, water didn't do anything. Now is the acid soak. So this is number 3. Okay, so this was the acid that the bone was soaked in.
The last one was water. The first one was water. The last one was water.
Okay, so here is the acid that the bone was soaked in. And so this time you can see it did turn white and cloudy. What does that tell you?
There was calcium.
There is calcium in the acid. What that means is that the acid pulled the calcium out of the bone and into the acid. So the water-soaked bone still retained all its calcium. It stayed in the bone, not the water. The acid-soaked bone lost its calcium into the solution.
So that means like the bone was like deteriorating.
Mm-hmm.